This is a companion video for week 4, exercise 4 of ARC413. So we're here. Remember, we're syncing with your design studio this semester. A core goal is to develop simulations that you apply immediately. So we want to quickly get into the site. You should be doing a review this week with study models. So let's just take what we've been talking about and apply it to a site. So here's a site that I made in CAD Mapper of a location in Hoboken. I picked it because I know it and it's got a hill. So I built it in CAD Mapper. I could have done it in SketchUp very easily. If you haven't built a site context model yet and you want help, just ask me and I'll help you with it. Um, anyway, so here's the model that I generated with CAD Mapper. Um, the first thing we should talk about. So remember we've been doing quantitative LEED 4.1 daylighting studies in the last simulations the last 2 weeks. But you guys have been for a while doing site context daylighting. Typically you do solar studies, and I often see them. They're like this. You're out here somewhere, maybe you turn the sun on somewhere, and you scroll through, and you act like that's telling me something. You do a solstice, summer and winter at a certain time. Um, remember, the simulations are only as good as your understanding of what you're trying to learn from them. Um, solar studies really, I mean, unless we're doing an urban design project that's all about, a large area, we need to see the site and we need to see some kind of massing of a building so that we can understand how the site is interacting with what we're thinking about. So let's just start with a simple. This is um, the 125 by 125 foot rectangle that we used last week. That we did a third floor, or I mean, we did an individual floor of a medium office building into daylight simulation. So let's just start with this. So the point is here, you don't need windows, you don't need really anything to start doing daylighting and thermal and other analyses and the quicker you can get it to the site, the better. And we'll see some examples of that in this video. So my point is, I just need a box, right? So I just extruded something that's 125 foot square by 39 feet tall, um, and then I can move it around on the site and see what effect it or what effect the site has. So let's just as a starting point, let's do what you guys have done before and create some basic solar studies. Um, in Rhino, there's two ways. Well, there's more, but there is a built-in sun tool in Rhino that's in uh, available here. Right, you can turn it on, and I'm using that first because I can create snapshots. Um, for example, if I was in SketchUp, I would have a different way of doing this. But here, I find the best thing to do is if I want to make a summary solar study, is to create snapshots. So there's a snapshot tool, and basically it's just or one of the built-in plugins uh, that allows you to save um, screen basically scenes. So here I'm starting with winter um, solstice at 9 a.m. and I can click through. So now I'm at 12 and then 3 on the winter solstice. I can then go to the summer solstice, 6 a.m., 9 a.m., 12, and 3. And the point I'm making here, though, is that if I'm out here somewhere, I'm not learning anything, right? It seems obvious, but a lot of people are not getting in and saying, okay, what's actually happening on this site? Um, like, for example, 3 o'clock in winter is very different than 3 o'clock in summer for the massing that I'm considering, right? So make sure that and then if you're creating graphics, make them so that they are telling a story about the thing that you're considering. At this point, we could move this mass around. We could make multiple versions of it and create these same visual simulations. Let's talk a little bit more about how we, about the visuals here. Um, so for example, if I'm at this view, and by the way, why did I choose this? Well, I face south directly downward, which is the typical to have south normal to this axis, so that whenever you're looking at a model, if there's no compass or if you're quickly reviewing, that you can orient yourself. Anyway, so here's one uh, graphic display. Here's another for the same scene. The only difference is the sun setting. So let's look at how those are altered. If I go to settings here and start at in the render tab in the documents properties for settings. So this is going to be only local to this file. Um, there's a bunch of different uh, settings to choose from. And so, for example, I have no environment here. That's how I got this darker look. Um, this studio setting is something I'm not going to get into it, but that you can edit and create a different um, set of solar effects. The way that we edit that is if we come back into options and come down to views and go to the rendered view, um, shadows, we can adjust our shadow visuals here. Um, Somewhat this will depend upon how good your graphics card is. If you get the sharper the images, the more calculations it takes, and so therefore the more um, computing power you need. But anyway, so just to do the basic visual solar study, those are some tips. And those are useful, and they're not only useful as graphic outputs for your documentation, they're also useful to quickly consider as you're doing something more complex in terms of a simulation. Remember also that we can use the site analysis sun shadows. The way it works is if you turn those on, it will turn off the sun in Rhino. So I think it's nice how that is automatic, and then we can scroll through this. This is what I typically use if I'm want to quickly understand something about shading. Um, and I'll often go here if I'm looking at, for example, a daylighting study like we did last week, just to get a feel for what's going to happen if I, if I put on some shading and I can run quickly through the year and visually get a feel for how much the shading is going to affect my design. Then I can go and do the quantitative analysis simulation that takes a little longer, but is gives me permanent outputs. The final thing to remember about this site analysis sun tool is that we can turn on the path of the sun. It's down here because this is where the origin is on the reference plane, but we can move it. So I can set the position of this um, wherever I want. So if I want to put it right in the middle of my building, I can put it there. And I can change its size. So I can make it much larger if I want, or um, whatever makes sense for me. And then now, this is a graphic showing us where the sun is in terms of the solar window, which is if we're here, this is what the solar window would look like if we had a graphic, on a 2D graphic. Okay, so those are powerful visual tools, but we're not getting any quantities out. And one of the main goals of this class is to quantify this stuff, um, and to design to benchmarks that are part of our program. Okay, the next level of daylighting analysis would be a radiation map. So if we come back to our drop downs in Climate Studio, and I choose radiation map, we see here similar inputs that we had for the daylight analysis, the daylight availability analysis that we did last week. That's a great thing about Climate Studios, that a lot of the inputs are the same. So we have to decide. So what are we doing here? We're going to do a map of the solar energy hitting surfaces. So we have to first define those surfaces. So if I go to the Materials tab, whatever I want the sun to hit, I have to give a material to. So what I've done here is the buildings. So here, if I turn my buildings on and off, um, those buildings, I just put concrete, exterior wall concrete. And what's the difference between these materials? They just have different, in this case, properties of how light is absorbed or reflects off of them. Okay, and then for the topography, I just gave an asphalt material. And then for the building itself, I gave it also concrete. Uh, okay, and then other than materials, all we have to do is define the surfaces that we want our radiation map to be um, calculating for, or calculating radiation for. So in other words, we have surfaces that are basically blocking the sun or reflecting the sun, and then we have surfaces that uh, we want to understand how much sun is hitting them. So in this case, it's going to be this building. So I've already done it here, but let me just show you how it would work. If I want to add a surface that I'm calculating a radiation map onto, I just select that, um, this far left tab, hit enter. We see I've already selected it. And I named it main, and now I'm going to turn it on. And so remember that we have, let's edit this again. We can set the sensor spacing, and other inputs here. You can just usually leave it as the default for now. Um, on a rectangular box like this, this is plenty. It's every 16 feet here, so they're pretty far apart. Of course, the more sensors you have, the longer the simulation takes. So that's the calculation you're making there. Okay, so of course, the thing I did not that I have to remind ourselves always that we need a climate file. I just chose New York Kennedy Airport for this one. All right, I'm just going to run this. Probably won't run the whole thing, but just show you how it works. All we had to do was climate. We're doing a radiation map study, materials, surfaces. And if I run it, I immediately start getting this output. Remember, we typically have, I think, or maybe always have 100 passes in these simulations. This one's going pretty quickly. So what are we seeing here? Uh, First of all, let's just see if it makes sense. We have more on the roof. That's typically going to make sense, unless it's a pretty strange site. In the south, we have a little bit more than the west. The east is less than the west. Why would that be true? Um, well, because of this building, right? So it's shading. Well, that's one of the main reasons. Okay, so it's working. Um, this is the same. Let's see. This is this one. Let me turn. Now I'm going to turn off. Let's go over these basics too. I'm turning off my building. For radiation map, um, pretty much for any simulation, if you come to this white arrows and deselect, it will turn off the simulation, right? So I can turn back on the building. I can come back in, and if I don't want to see the dots on it, I can turn it off in the simulation, and I'm back to where I was. If I come into my results tab, and I select this first one, maybe I'm going to want to turn off the actual geometry in the graphics window so that I don't have that ghost. And now that this is the model I've run. So what would I do with this? Well, I could, of course, I could move my geometry and see if there's an effect by, moving it 10 feet, in this direction, or, further back this way. And run that simulation again, and I could very quickly get a comparison. So that's useful to do. Another thing I could at this point quickly think about shading. So I could add um, some shading. Let's see. Let's just do. I think this is actually the shading I use for the second um, simulation. Uh, but it could be much simpler, obviously. And so I ran a. Let me turn off the building. I ran another simulation. Let's do this too. Let's go to right now. This whole time I've been in the rendered view. By the way, I realize these videos I'm going fairly quickly. They're also sort of long because I talk about a lot of things. So pause them, uh, scroll through them if this is something that's not interesting or you don't need to know. Um, and use them as a resource that's not just me talking, where you're going back and reviewing what I'm saying in terms of how I'm quickly pushing a button up here. What button am I pushing? You can pause and slow the video down and see what my workflow is. Okay, anyway, the point is this is the first results without the shading. This is with the shading, quite different. Um, so I'm going to turn off the shading just so we can see um, what's going on. So uh, without shading, with shading. One thing we notice right away is that, let's say on the south side, if we go back to the original, it's fairly consistent across the surface of the south facade. By the way, this is kilobtu's per square foot. We can let's look at our outputs too in the radiation map. We can change from total solar exposure to direct, which is going to be just the sun that's normal to the surface, or that's not. I'm sorry, that's not true. That's not bouncing off of clouds. Indirect would be stuff bouncing off of clouds, and the total is the two together. We talked about this in the first week, so go back and review that if you don't understand it or ask me. We can set the hours to warm or cold, in other words, heating or cooling, which could be helpful. And if we scroll over the graphics window, each sensor, based on the settings that I've got here that you can play around with and change, um, we see the annual average on that one sensor. So we have a lot of access to different information here, and we can um, export the data if we wanted to. We also have this summary here, which is helpful. So it tells us what is what was on in the simulation. So we see in the second one we had um, these shading layers on. That way we don't necessarily have to be viewing them while we're looking at the graphics, so we can see more clearly what's happening, by mousing over. Anyway, so I'm going to go to full year, all hours. And the point I was making here is that, so without the shading on each face, it's pretty consistent from the bottom to the top. With shading, you see we get this gradation. Why is that true? Well, um, I guess, right? We're learning here that this overhang is shading uh, this floor or this part of the building. And this overhang is shading this, but it's also shading this. And so this overhang here is shading this and this, right? So we get this uh, collective effect from more shading. That's not something that you would necessarily have seen in, you know, a solar study, on this level without a numerical input. So again, even in these simple simulations, we see the advantages of having some numbers. Um, and so we could pretty quickly attenuate or come up with some thoughts as to design interventions we want to try, um, just in a simple massing stage. Another thing we can do is start thinking about photovoltaics, renewable energy at this point. What I've done here is simply just take this roof and copy it to move it to different locations to simulate what the roof would be like in a different siting of this mass. And so just again with this simple, very quick radiation maps are very are quick simulations to run. We can see, okay, in the original massing setting, we're at 420 here in the middle, kilobtu's per square foot. Here we're at 440 or around that, and here 459. So if we go from 420 to 466 look like, and if I just quickly, what was it, 420 divided by 466. Again, these are approximates completely. It's about a 10% difference in the amount of sun hitting the roof in this location than is in this location. So all things equal, and if we were really trying to focus on being able to have a surface that would collect a lot of sun for solar electric production, we might want to consider a different site than one that's right here. Um, and at this point too, we can really start to quantify and understand maybe we don't need to do that because maybe we'll have plenty of electricity being produced based on our goals. Um, we also are going to learn another quick and very efficient PV workflow using Grasshopper, where we would get we could get an actual site energy use for this building if we could give it an envelope that we could quickly define and set some other parameters and get and then decide how much of this roof we think would be able to have PV on it, photovoltaics, and we could get an energy balance at this level of massing. So we'll learn how to do that in some other workflows or some other weeks, and then you'll be able to apply that to your studio project also. Okay, so where are we? We've been thinking about daylighting in several different ways. Uh, we looked at basic solar study um, in the old school way that we've done before. Then we moved up to radiation mapping as a way of thinking about things like shading and photovoltaic production at a very quickly at just a very simple massing level. If, however, we were a little bit further along and we had some idea of of our window layouts, and we could also bring the simulations we've already done, like last week, in at this stage. And we need to do that whenever you've um, what we were doing in the previous weeks without being in the context of the site is really just an exercise. We have to be in the site to understand what's really going to happen for our project. So let's look at that. If I come back and let's say we're going to run, I'll turn this off and see how I've got this organized here. I've got my site. I can turn on and off. The massing model, which is that the shading and the building that we had before that I can turn off on and off at any point. And then I have a daylight model in here that I can set up quickly to be, this is an approximation of, again, pretty early stage idea of the building. Sorry, I paused for a second. I realized that I deleted a window at some point, so I just want to put it back in. Um, okay, so let's look at the simulations we did last week in the context of our site. First, I ran a model as we did last week without the site, and let me turn off my roof. Remember, I still have a ceiling here that I can see through. It's on wireframe. Um, okay, so this is the building that we had last week, um, doing a daylight availability analysis, which remember again was this. And we're in this class we're designing to lead 4.1. And so without the building context, the site, this was our results. And if I just add the site, do nothing else, um, this is my results. So let's see, no no site, it's a pretty big difference, right? And we can sort of have intuited what the main change is. It's this building on the east is doing a lot of shading. So without the site, we get a lot more sun here on the east than we do with the site. Okay, so that's sort of an obvious thing that obvious fact that we might guess, but now we have some real information that we can, even at this early stage, because you could even in a massing model, you could throw in some windows and be thinking about some, how much glass do I want to have, and is there a difference between glazing on this floor and that floor? Okay, so what would I start thinking about when I'm looking at this data here, if I'm at this massing model stage? Well, I might think, let me try to see if I can, do I want to think of a different shading strategy for the west than for the east? And so um, in the massing model, I had created these different shading, let's see. Um, so the first thing I did was and we can see here I have just the west horizontal and vertical shading. And when I ran that, so in other words, I have shading on the west side, but none on the east side. Um, I got uh, I got rid of, so I'm going to switch back and forth between the two. So without the shading, I'm here. So by adding this shading on the west, I and again, I need to dial in more while I can look at the here's the um, so this was just the average lux. This is the lead 4.1 um, annual solar exposure. And so the yellow places are where we're overlit. And the difference between my site without shading and with shading, I've basically, by adding the shading, I've solved the over lighting porch problem for the west side. And I don't really have much on the east side, or not, or I don't think I would want to use this or need to use this same sort of extreme shading layout to solve the problem here. So maybe I try just doing a vertical, I'm sorry, horizontal, which would be these. Oops, vertical. There we go. So the next thing I tried was to just add horizontal shading on the east and the south, and that's this. So at this point, then I've got a really good daylighting approach. I've got my full 3 points in lead 4.1. Again, we're not just chasing points, but these are good indications for us of, that we're meeting some goals that we set for ourselves, which is daylight autonomy. So we're over 75%. So we have very good daylight autonomy, and we are less than 10% on average for being overlit. So this is a good design. Not saying that architecturally it's what we want to do, but we have some ideas now, right? In addition, then we could, from here, we could, rotate the site and very easily and compare. So let me just turn off all this other stuff. So this is the massing model rotated 30 degrees. Um, and originally, let's go back to this one. Um, so if we go to, this is north, south pretty much. So we're already, 15 degrees east of south. And so then I just rotated it to be 15 degrees. I'm sorry, that's west of south. This is east of south. So we're rotating at 30 degrees. And I took off all of the shading. So we can see here that in my original approach, I've got a fairly even overlighting profile. And if I go 30 degrees, or if I rotate 30 degrees, I've solved the problem on, for these portions of the building. So I might even be, maybe this is, a part of the building where we want a lot of sun coming in. Maybe right here, we're a plant, um, I don't know, hydroponics company. We want to have a portion of our building that's really sunny. So we can quantify that. We already, and for both of these, we have good sun, good uh, daylight autonomy. So we're dialing in, we're looking at overlighting, we're looking at the amount of lux that we have. If for example, we're trying to have some work areas in here, we'd have to deal with this because these are pretty, this is pretty overlit in terms of workspace. We could do glare map, a glare study. All of that could be done in the context of the site. It needs to be done in the context of the site if we're going to have an accurate understanding. Okay, so that's essentially what I wanted to introduce. I hope the point's clear that in this class we are dealing with skill building. So we're coming up with exercises that are isolated so we can learn the skills, but we're architects designing buildings, and so you always need to be thinking about the site. And so as quickly as possible, um, bring these workflows into your studio project and also include the site as quickly as you can, because the rewards are massive if you are organized in that way. All right, that's all I've got. We'll see you in class.